What up, y'all? I guess today I want to talk about something very fundamental. I think this happens around third or fourth grade. This is where we start really losing students, and that's when we talk about fractions. So there's a relationship between the operation of division and fraction. So I'm going to start with the operation itself and then kind of flow it into fraction form. So this says 10 divided by 2 equals question mark. I think everybody knows the answer to that. So 10 divided by 2 is equal to 5. But I want to focus on that symbol right there. That one right there. The division symbol itself is a fraction if you think about it. That dot represents the numerator while that one represents the denominator. So when you see 10 divided by 2 is equal to 5, we can change that into a fraction form with 10 over 2 equals 5. So by the time you get into high school, normally we don't write division symbols like this anymore. Everything is in terms of numerators and denominators, and then we start getting into another format of writing these numbers. You can add or subtract fractions if and only if, that's emphasis, if and only if they have a common denominator. So let's think about this. Let's do some regular addition. If I did 1 plus 2 is equal to 3, no one will argue that. But if we look at those as fractions, that's 1 over 1 plus 2 over 1 is equal to 3 over 1. Notice that 1 carries throughout the whole problem. So there's my 1 over 1. 2 over 1 is equal to 3 over 1. You cannot add those two unless these denominators are the same. Can't do it, all right? They have to be the same before you add. For the students that never listen, they'll see this and they'll say 2 plus 1 is equal to 3. Then they'll look at the bottom and say 3 plus 4 is equal to 7. And that is totally false. There's no truth to that, all right? But what they can do is, if you pay attention to what's going on here at the bottom, since this one has a 4, use that 4 over here. Times 4, times 4. You got to do that to the top and bottom. And that 3, since it don't have 1, use the 3 on the top and bottom. See that? Now we got the 3's over here. Now look what happens across the bottom. If you multiply that and you multiply that, it looks like you're going to get a 12 both times. That's what we mean by getting a common denominator. The common denominator is 12 now. Now if you look at the numerator, now you have an 8 if you multiply that, and if you multiply that, you have a 3. So what we're really looking at is an 8 plus 3. So your final answer should say 11 over 12. If you compare 11 over 12 to 3 over 7, they are two totally different numbers. All right, so you got to use your common denominators properly. All right, so let's look at this. 2 over 3 plus 1 over 4, see that? 11 over 12. So you know why it happens now. It happens because we get a common denominator, all right? Common denominator. Here's a visual representation of that same problem. Notice I have 2 out of 3 shaded, and I have 1 out of 4 shaded. So I'm adding, what's 2/3 plus 1/4? Same problem, visual representation. See, this one has 3 different parts. 1, 2, 3. This one has 4. 1, 2, 3, 4. So you just can't add that 2 with that 1 and think they mean the same thing, because they don't, because this is a part over a whole, just like that's a part over a whole, all right? But what I can do is I can cut these down into smaller pieces and cut these down into smaller pieces so that I can actually get the ratios to match up. I'm about to show you what I mean in 1 second. All right, so I'm going to cut these in so that these have 4 in each one. So 1, 2, 3. 1, 2, 3. 1, 2, 3. So remember, at first we were looking at a fraction of 2 over 3. But now I cut them down into smaller pieces, and we're about to count that and see what the part over whole is now. Notice I didn't change the shape, I just cut them into smaller pieces. So I'm going to count it. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 8 out of 12 now. It's 8 of them shaded, but it's 12 slices now. 8 out of 12. So I had 2 over 3 right here, cut it down to this. Now I'm looking at 8 over 12. Got it? 2 over 3, cut down, 8 over 12. So now I got to come over here and cut these down I'm gonna cut these down so that it has 3 slices in each, all right? I'm about to cut this one down too. So we're gonna count this up too. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 slices. How many are shaded in? 3 out of 12. Since every piece is the same size now, every piece represents 1 out of 12, just like this small piece represents 1 out of 12. Now I can add the numbers up. I have 8 of them over here, and I have 3 of them over there. And we all know that 8 plus 3 is 11. That's the same 11 out of 12 that I got earlier. That's a visual representation of how these fractions actually work. Same example, I could talk about this like a million different ways, right? I think normally if we look at it in terms of a circle, it makes more sense because you all seen pies and cakes and stuff like that are circular. They'll start understanding it then, though. And the reason we have to have common denominators is that 2 out of 3, look how big those 2 slices are. Look how big that 1 slice is. So this 2 that you see at the top isn't the same size as that 1 that's represented at the top there. And since they represent 2 different ratios, like that 2 out of 3, you can't just say 1, 2, 3. They're not even the same size. You get what I'm saying? That's why we have to cut everything down so that they are the same size on each slice. You have to excuse me, I cut them into smaller slices now. So now I have 12 of them total. And now out of that, 8 of them are shaded in. So I did the same thing here. Now I have them cut into 12 separate slices, and only 3 of them are shaded in now. Got it? Yeah, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I got 11 out of 12 now. 11 out of 12. So parents, I guess it's for the parents. By the time your kids get to like the 3rd or 4th grade, when they start talking about fractions, you can actually save some money if you buy some pizza instead of paying a tutor and start cutting them slices up yourself. Just an idea. Now, if you do that, the whole pizza idea I was just talking about, it's going to be a weird thing to ask the Pizza Hut or Papa John's or the Little Caesar, whoever you buy your pizza from. If you get a circular pizza, tell them don't cut any slices for you. You'll cut them yourself, all right? Or you can just buy a frozen pizza from the grocery store. You cut them into slices yourself. You can start adding up fractions that way. It's still cheaper to do that because the rate I'm going to charge you per hour, just get the pizza. I can show you how to do that.